Well, hello Internet, and welcome to part 1 of my statistics tutorial. This is a continuation of the math of machine learning. Previously, we covered probabilities, and you should probably watch the probability tutorial first, but you don't necessarily have to. I'm going to cover mean, median, mode, standard deviation, coefficient, variations, and numerous other different formulas with all the code included and a whole lot more, and I have a lot to do, so let's get into it. Now, statistics is basically the science of collecting and analyzing data taken from a sample of a population. And the population is going to represent all items or people of interest, while a sample is going to be a subset of the population that we can analyze. And basically, we would use samples because it's impossible to go and poll, say, every single person on Earth. And we are mainly going to focus on successes or results we are looking for in a sample. And examples being things like age, meaning are you of a certain age? Are you a car owner? Are you a college graduate, homeowner, etc.? And in this little pictogram you can see here, uppercase M is going to represent the successes in the population. Uppercase N is going to represent the total population. X is going to represent successes in our sample, and N is going to be the total sample from our population. Now, there are many different types of data. First, we're going to talk about categorical data, which is going to describe what makes a thing unique. So you have things like age, are you a car owner, sex, graduate, or basically any answer to a yes or no question, meaning are you of this age, are you a car owner, and so forth. Numerical data is going to be either finite, meaning that it has an ending value, or infinite. And you don't need to memorize these things. These are just things that I'm pointing out that I will review again later on. Continuous data is data that can be broken down into infinitely smaller amounts. So we're talking about things like distance or height or weight, where you can constantly divide by 2 indefinitely. Qualitative data can be either nominal, meaning named data, and it is data that is used for naming something which doesn't have an order. So, for example, race would be an example because there are many different races, but there is no ordering to them. Ordinal data is also named, but it has an order. So we could say things like bad, okay, good, or great. And then we come to quantitative data, which is like a ratio or an interval being an amount between two defined amounts. Like if you ask somebody to pick numbers between 8 and 16, for example. Now, there are many different ways to visualize data. This is a cross table, and what it does is it shows relationships between rows and columns of data. And frequency shows how often something happens. And here we can see that when we sampled 100 random men, that 78 were men that didn't exercise. With pie charts, each slice is going to represent a category, and the size of the slice is going to represent its frequency. And what differentiates it from other charts is that it must always equal 100%. Bar charts have bars, hence the name, that are going to represent the categories. And then, once again, the bar's length is going to represent the frequency. And then we have Pareto charts, which list categories in descending order and include a line that's going to represent the cumulative, or the sum, of all of the frequencies from all of the different bars. And that brings us to our last example, which is a frequency distribution table, which is going to focus on the number of occurrences or the frequency. And here we list a range of test scores and how many students scored within that range. A histogram is going to differ from a bar graph in that histograms show the distribution of grades in a range in this example versus categories like we saw with our bar graph. And you should also note that histograms are often drawn with the bars touching versus being separated. And that brings us to our first calculation, and these are going to start off extremely simple and get much more complicated. So basically, the mean, or the average, is going to provide an average value by summing all of the values and then dividing by the number of components. And mu, in this situation, is going to be used to represent the mean of the population, while x bar is going to represent the mean of a sample. And while it can be very useful, meaning mean, often outliers are going to dramatically affect results. So for example, let's say we had the numbers 1, 2, 3, 4, 5. That would have a mean of 3, which would make sense. However, if we had 1, 2, 3, 4, 100, that would give us a mean of 22. And I think you can see how dramatically just one outlier can dramatically affect your results. And now what I want to do is jump over and show you the code for calculating mean. All right, so I imported math. That's all I did. And this is going to be very simple. I'm just going to say mean. Like I said, these are going to get more complicated as we go on. So this is going to receive a list, and it is going to calculate the mean. So I'm going to call this value sum, which is just going to be I'm going to use the sum function here to sum all of the values in the list passed into this function. And then I will just return that sum divided by the length of the list that was passed inside of it. And now what we can do is just come outside of here and say printf and mean, and then inside of here say mean, and we'll just do 1 and 2, 3, 4, and 5. And if we run that, you're going to see that it kicks back that the mean is 3, exactly as we expected. And that brings us to the median. Now, the median is going to try to eliminate the influence of outliers by returning the number at the very center of our data set. And if you ever have an even number of components, obviously there is no middle. So in that situation, what you would do instead is take the two center values and then return the average. And now I'll show you how to calculate that in code. All right, and all this code is going to be available, of course, in the resources directory. So to calculate our median, go call this median. It's also going to be passed a list, and it's going to say if the length of items inside of our list and modulus 2, and that's going to come back as false if it's even, true if it is odd. If I do this, that is equal to 0. All right, so there we go. And then in that situation, I will go and round the length of the arguments plus 1, and then divide that by 2. And then I will go j is equal to I minus 1, and then return args and I plus args j divided by 2. Otherwise, we're going to come in and say else, and I'll say k is equal to, and round the length, and again, for our list, and then divide by 2. And then return args and k. And there we are. And then we can just come in here and I can call this median instead. And then let's just have this be the same also. So we'll say a median like that and run it. And you can see it comes back as 3. And if we would come in and change this to an even number of items, so we'll throw a 6 inside of here as well and run it, you can see it comes back as 4.5. So there you go. That is how we would calculate the median. Now, the mode is going to return the value that occurs most often in your list of items. And if components occur at an equal rate, that means there is no mode. And if you have multiple values that all have exactly the same number of matches, in that situation, you could actually have more than one mode. So let's go and calculate that. So we will continue onwards here, and I am going to say define and mode, and the mode is going to receive a list of items as well. And what I want to do here first is I want to count how many times values show up in our list, and I'm going to put those inside of a dictionary. So I'm going to say dictionary values is equal to, and how I can count these up is go I and args count for all of our items in our list, and then cycle through all those items. So for I in args. All right, so that's going to give all those different items and put them inside the dictionary along with the count for each one of them. And now what I want to do is I want to create a list of keys that have the maximum number of occurrences in our list. So I'm going to call this max list. And to do so, I can say K for K V in dictionary values and items. And then I will say if V is equal to max dictionary values dot values, like that. And then what I can do is return that new list that's generated with all the maximum values inside of it. We can then come down here and with the mode, let's just get rid of that altogether and change this to mode. And I'm going to change this to mode. And then I'm going to put 1, 2, 3, 4, 5, and 5, and 4. Save it, run it, and you can see that the mode comes back not only as 4, but also 5. And of course, if there was only one match inside of there, we would only get one mode as a result. All right, so cool stuff. Now, variance is going to measure how data is spread around the mean. And there is both a symbol for variance of the population, as well as variance of the sample, as you can see here on the screen. And to find it, what we're going to do is we'll first calculate the mean, and then we sum all sample values minus the mean squared. And then, after we do that, we divide by the number of samples minus 1 in the case of getting variance of a sample. If you were getting variance of a population, you would divide just by the number of samples. But like I said, you're always going to use samples, so this is what we will use in this situation. And you can see here, if our sample was 43652, we calculated the mean as 4, and then we came in here and performed our calculation. We would find that our variance was 2.5. So now I'll go translate that into code. All right, so we're just getting more and more complicated here. Once again, the variance is going to receive a list of items, and then after it gets that, we're going to have our mean value, which since we have all of our functions here, we can go and automatically use those, and we won't need to do anything else. I will then form my numerator by giving it a value of 0 to start. I will then cycle through all of the items inside of my array, and the numerator is going to be plus or equal to, and I will pull an item from the array and subtract the mean from it, and then take that to the power of 2. And after I do that for all of those items, I can then come in and get our denominator, which is going to be equal to the number of items that I have inside of my list minus 1. And then we can just come in and return the numerator divided by the denominator. Good stuff. And then we can come down here and change this to variance instead. And let's use the exact same values we had before. So we'll say variance, get rid of this, and instead put 4 and 6 and 3 and 5 and 2. And run it, and you can see we get the exact same value, which is 2.5. Now, because we square values with variance, that is going to give extra weight to outliers. And as we talked about previously, outliers are bad. And so for this reason, we find the square root of the variance to find what is called the standard deviation. And the standard deviation is going to be large if the numbers are more spread out, and lower if they are closer to the mean. And once again, just like variance, it is just going to be a measure of how spread out data is around our mean. And you can also see the symbols for standard deviation for population and standard deviation for sample. So let's go and calculate standard deviation next. Standard deviation is going to be very easy because we're just going to use variance and then square roots. So we will call this standard deviation, and it is going to receive a list, and then it will just simply say return and math and square root, and then we will call a variance, the variance function, and we will pass in our array to that, and now we can get our standard deviation. So standard deviation, and we will call standard deviation, and let's use the same values because why not, and run it, and you can see there is our standard deviation. All right, so good stuff, and we're going to be using standard deviation and variance and all that with formulas that come up. Now on to our next formula. That is going to be called the coefficient of variation. And what it's going to do is it's going to compare two measurements that operate on different scales. And here, what I'm going to be comparing is miles to kilometers. And even though they measure exactly the same distance, because they use different units, that is not seen whenever we calculate the standard deviation. And the coefficient of variation is going to fix this. So by dividing by mean, we're going to see that they actually have the same dispersion. And as you can see here, whenever we do perform that calculation, both for miles and kilometers, we get a coefficient variation of 0.1721, showing that they are dispersed in exactly the same manner. So now I'll go write the code for that. And guess what? That's going to be really simple too. So let's come in, and all we're going to need to do, because we have all our other code written here for us, is go coefficient variation. It's going to, of course, receive a list, and it's going to return standard deviation, and we will throw our list inside of there, and then it's also going to be divide by the mean, and throw that in there, and that's all we need to do. And then we can come down here. Well, let's go in here into this one first, delete that, and I'm going to perform two of these. I'm going to do coefficient variation, and this will be specific for miles, and you're going to see they are the same. So I'll go and get rid of this. So coefficient variation, and we will do exactly the same example that I just showed you, just so we can have consistency here. So I'm going to say 3 and 4 and 4.5 and 3.5, and then we'll do the same thing for kilometers. So I got this, paste that there, and change this to kilometers, and get rid of this. Could have wrote another formula that converts miles into kilometers, but I didn't do that, but you could if you'd like. All right, so threw all of that data in, and if we run it, we're going to see that we get exactly the same, well, almost exactly the same calculation. All right, so there you go, and I think you're starting to see how awesome and numerous different ways we can monitor and analyze data, and I will show you more. Because up next, we have covariance. And what covariance is going to tell us is if two groups of data are moving in the same direction. And here what I'm going to compare is whether the earnings is going to affect the market capitalization of a corporation. And if you don't know what market capitalization is, it is basically the total value of all of a corporation's stock. So the total value of a corporation, that's what it is. So what we want to do is figure out if earnings, meaning how much earnings are expected from a corporation, has a major effect on the market cap. So you're going to make this calculation by plugging in the values, minus their mean, and then multiply. So we will go and get the X value, for example, 1532, plug it in there, and subtract from it the mean value for market cap, which would be 1532. We would take 58, throw that right here where we have YI, subtract from it the mean for earnings, and sum all of those for all of our different stocks. And if we do, we would say we'd get a value of 5,803. And we know from this number, if the value is greater than 0, that means those values are moving together. However, if it's less than 0, then we know that it's moving in opposite directions. And if we got a value of 0, that means that they are completely independent. But this 5,803 number is kind of arbitrary. Like, what exactly does it mean? Yes, I know it means that they are moving together, but by what percentage? Is it a great amount? Is it a lesser amount? Well, that brings us to our final ways of analyzing data, at least in regards to what we're going to cover in this tutorial. And that is called correlation coefficient. And yes, I'm going to show you how to write up the code for covariance as well, because I need it to figure out the correlation coefficient. So what the correlation coefficient does is it's going to adjust the covariance so that it is easier to see the relationship between X and Y, or in our example, market cap and earnings. And its value can't be greater than 1 or less than -1. And the closer you get to 1, the closer the relationship between the values. And in this example, what we're going to do is plug in the standard deviations of market cap and earnings. And when we do this, we get a value of 0.66, which means, yes, indeed, market cap and earnings have pretty good amount to do with each other. Not a great amount. That would be closer to like 90, but there's definitely some influence involved here. And in situations in which we had perfect correlation, you would have a value of 1. 0, once again, is going to show independence, and a negative value for correlation coefficient is going to show that they have inverse correlation. So let's go and calculate both of those. And so what we're going to do is, I did not show you how to calculate covariance, but I shall right now. So covariance is going to receive a list of values, and I am going to use a list comprehension to get all the values stored in the first and second list, because remember, we're going to get a list of market capitalization and another list for earnings. So to get our first list, I will say list 1 is equal to, and I, and 0. This is going to represent the first list item. 4, and then I want to go and get all the different list items out of there for both of those, and then I will get my second list as well. Change that to 2. Of course, that means I have to change that to 1, and that's all I need to do for that. And if you're wondering what the list is going to look like, because that would probably make this a little bit easier to understand, I will show you. So I'm going to say MD and list is going to be equal to, and then inside of here will be 2 different lists. I'm going to have the market capitalization one first, and 615, and then another list inside of here, which is going to be the earnings amount. And this is in billions of dollars, if you're wondering. So that's going to be 58, 35, 75, 41, and 17. All right, so those are all the list items that we'll be pulling apart in our covariance method we have here. So what are we going to do next? Well, what I want to do is pass those lists to get their means. So I'm going to call this list 1 and mean, and I just pass the list items in and I will get them. So, and we'll just call, there's list 1 and 0. Going to do basically the same thing for list 2. Oops, get rid of that inside of there. All right, that's better. And then I'll change this to list 2 and change this to list 2. Everything else there is exactly the same. Oh, I have to put a star inside of here though. And there we are. And everything is good now. And what else am I going to do? Well, now I'm going to go and define my numerator, give it a value of 0. And at this point, we must have the same number of elements in each of our lists. So I'm going to say if length, and we'll say list 1, 0 is equal to length of list 2. Well, in that situation, then I know I can work with them. So what I'll do is I'm going to say for I in range and length. I can use list 1 in this situation. So I'll say list 1. Then what I need to do is find xi minus x mean, yi minus y mean. So I'll say numerator and add to this and go and get list 1 and 0, and then we will have I minus my list 1 mean, and then I'll multiply that times basically the same thing. So let's just go and copy this, paste that there, change this to list 2, and change this to list 2, and everything else looks right. And then after I perform those calculations, I can go denominator is going to be equal to the length, and I can use list 1 here, and that is going to be minus 1. And then I can say return numerator divided by the denominator. And then we could say else, and in this situation, I'm just going to say print. We have an error because the lists don't match up, so I'm just going to write error, because remember, we have to have the same number of items in each of our lists for any of this to work. And then I'll show you how to calculate our correlation coefficient as well. And that's just going to be correlation coefficient. And we're going to be using these formulas later on. Again, it's going to receive a list, and it's actually going to list with multiple different items inside of it. I'm going to say list 1 is equal to, and I'm going to use this same thing up here. So this list comprehension generated this for us. So I can just paste this inside of there. There's list 1, list 2, same exact thing. The difference here is I want to pass those lists to get standard deviations in this situation. So I'm going to say list 1 standard deviation is going to be equal to standard deviation, and then pass in list 1. And then I'm going to get list 2 standard deviation. So change this to list 2 and change this to list 2. Everything else is exactly the same. And then I can go and calculate our denominator, which is going to be list 1 standard deviation multiplied by list 2 standard deviation. And the numerator is going to be covariance, and pass in those same exact values. And then I can return the numerator divided by the denominator, like that. And that's how we calculate all that stuff. And then I can come down here and I can say that I want to get my covariance. So let's just change this to stock covariance and get rid of this. Change this to covariance and get rid of this part right here as well, and change this to MD list. And then I'm going to do the same thing for my correlation coefficient. So take this, paste that there, change this to correlation coefficient, and calculate correlation coefficient with the same list. And if we run it, you can see that we got the same exact results you saw on this slide. All right, so there you go, guys. Whole bunch of stuff. I think a great way to kick off learning about statistics. More is coming, of course. And like always, please leave your questions and comments down below. Otherwise, till next time.